Hello, my name is Christopher Tate. I want to show you how we can integrate our AI telemetry application with a tool called Apache Camel with Saga to implement a custom import workflow for data that can do some import process, and if any part of the import process fails, we want it to do something called compensation, which will revert the changes that we've made in the import process in the case of something failing. So this is kind of what it looks like with Camel. We start with a route that we call direct import data, and we initialize Saga, and then we call this to direct import GPU device data. So this will jump to this from direct import GPU device data and initialize Saga in this part, but it ensures that the Saga has already started with this propagation mandatory clause. And then it declares a compensation workflow, which is direct import GPU device data dash compensation. So if any part of this workflow fails, it'll jump to this compensation workflow instead, which is defined down here. So this compensation workflow is these are both long-running actions, and we give it a delay of 2 seconds, 2000 milliseconds, just in case something hasn't finished importing within this part of the code. And then we will call some asynchronous vertex code to compensate for the failure. But in this case, we'll call some asynchronous vertex code to import the data. So this is declared above right here. So the import process comes here, and it uses this API that we've built for GPU devices, and it calls a method called import data camel. And in case of failure, it'll call this import data camel compensation method. So here's the two methods. This one is the import data camel method, and below is the import data camel compensation method. This one is built to call a delete request on all GPU devices if there's a failure. And this one is built to query our Keycloak authentication server for a token, because all of the APIs are backed by zero trust and fine-grained authorization via Keycloak. So we need to authenticate to Keycloak with a client ID and client secret, which we do here by querying the. So let me just start this up and I'll show you how it works. So it's gonna try to run the import. So if I stop this, actually, let's see, I think I forgot a step. So let me run this application, and okay, it's running. And let me refresh. Let me confirm that there's no GPU devices found. Yep, that's true. That's what I wanted to check. And then we stop this server. And we can start it again. So I'm going to start it. I'm going to clear the console. And while that's starting up, I want to show you that we have configured a bug in our application here. So if the node name of a particular metric that we're pulling is worker 97 is equal to worker 97, then we add this bug to the SQL that we are using to insert query and insert data into the database. So that bug is there for one instance. And so here we come to Keycloak authentication time, and you see the auth host name is keycloak.apps.ods.nerc.mghpc.org, and we have an auth token URI of realms/realms/nerc/protocol/openid-connect/token, and we have client ID and client secret. And if all goes well, we'll come to this on success. And so we did get a valid access token here, which looks like that. Now we're going to query our metrics from the Prometheus Keycloak proxy. It's an application that we built in the New England Research Cloud to securely query ACM observability metrics remotely, but backed by Keycloak fine-grained authorization so that it's secure. So we can grant access to Prometheus metrics. And then here, let's see if this is successful. Yes, it is. We were able to get metrics data here, like DCGM, FI driver version. So we have data, metrics data. The next step is we have a list here that's 22 items long. So there's actually 22 GPU devices registered in our OpenShift clusters, according to Advanced Cluster Management Observability. So we're going to iterate through all of them as part of this data results stream for each. Let me make this a little bigger. And I still want to be able to see the workflow here. So it's going to import each of these records one at a time, but let's check for failures. So if we continue, we should see this one is imported successful, this one, this one, this one, this one, this one, this one. But this one resulted in a failure. So what is the exception? It says response status code 400 is not equal to 200. So if we scroll up here, SQL posts failed. Late. Let's see. I'm looking for. Here it is. Error. Syntax error at or near bug. So that was the bug that we introduced. Okay, so I want to continue here, but I want to set a breakpoint within this compensation code. So let me scroll back down and let's view. So it's showing blocking threads. So let's unblock those threads. So I hit continue. And let's see here. So what do we have here? We imported some of the records. Now, I think we ran into a problem with our Keycloak access token expiring, and it didn't run an additional step that I wanted it to because we spent so much time debugging. So let me clean up these records. I'm going to archive these, and then we'll be able to try this import process again without so many breakpoints. So I'm going to clear these breakpoints. We now have no GPU devices here, and then I set a breakpoint within this compensation code. So let me start and restart this process. So I'm going to clear the terminal. So it says importing all GPU device data failed because we had this earlier exception thrown related to bug. So it came to this import data compensation method. Whoops. And it did import a bunch of records, but it still warned us that the GPU device failed. So if I come over here and refresh, now it's not able to load this page because it hit a blocking thread, and it's because of our debugger. So I'm going to continue here and let this thread finish, which let this page load. And if you look, it says no GPU device found, even though it actually imported some data. So if we look here, we got a message, deleted all GPU devices created during failed import. And so it did hit our compensation code, deleted all GPU devices created during failed import, and then finished compensation for failed GPU device import. So what it did was it imported some records, but then it failed on one of them, so it cleaned up what it imported. So now we're back to no GPU devices. So let's go and fix this bug and show you that this works if we remove this bug. So I'm going to comment those lines out. Actually, let's delete them. So I don't want them in there. And we can stop and start this workflow again. So this is going to actually import data into the database. And so here you see it imported all of these records, and this time it successfully completed import of GPU device data, which is this message right here, successfully completed import of GPU device data using Saga and Camel. Pretty cool, huh? So everything's good. Let's refresh our page here, and you should see all of the GPU devices now. So this AI telemetry application is something built with my tools that I've been working on for many decades. Well, yeah, for the last 19 or 20 years, Computate. And so it's got built-in Keycloak, fine-grained authorization, and it's got API device generation and dashboard generation, like this dashboard here, so that we can filter on things like node name and cluster name. So if I type in NERC OCP prod, then should filter on, oops. There we go. Let's see. Filter test. Okay, let's try NERC OCP test 2. So that filters on the NERC OCP test 2 cluster, and this switches to prod, and we can switch to worker 97, which is here, 86. Oh, that doesn't exist. 98. Anyway, so that shows you. So what have we done? We've used Camel Saga to import data into a database, but when it fails, let me go back to, oh yeah, this is all running in Red Hat OpenShift, and it's actually running in Red Hat OpenShift AI, a workbench image that we built for building Java applications, which is available at github.com/nerc-images. And here's our VS Code Java image. So you can get more information about this image here. And so this lets us do VS Code in the browser. It's pretty cool. And we can directly run our application in development from OpenShift AI. So if I stop this service now and go back to this page, you'll see if I try to refresh, it says application is not available. So I go back to my browser and I run and debug this main vertical here. That's where we run the import process. And if I come back here, the site is back alive. So if you're interested in learning more, you can go to computate.org and learn more about my products for deploying smart applications and microservices like PostgreSQL, database, Apache Solr search engine, Apache Zookeeper for cluster management, and much more, as well as my Computate Smart website builder, which is what we use to build the AI telemetry application in the cloud like this. So that's a little intro to the AI telemetry project, and feel free to check out our more information about AI telemetry at the AI Telemetry Community webinar page. You can join us, and we have the code right here, the link to the repo with documentation and architecture diagrams and information about the operators and what it's for and what we're doing. So feel free to join that community with us. We meet together 5 times a week, and thanks for watching.